Assalamualaikum warahmatullahi wabarakatuh. Okay, today we come to the new chapter 3, modeling with higher order differential equation. Okay, for this chapter, we have two parts. The first one is spring mass system, and the second one is RLC circuit. Okay, for the spring mass system, we have three conditions. Okay, free undamped motion. Okay, the first one, free undamped motion. The second one, free damped motion. And the third one is driven motion. Okay, for the first system, free undamped motion. Okay, so this image, we have the unstretched spring. And the second image for B, we have the mass attached to the free end of the spring. Okay, from the Hooke's law, the restoring force, okay, Fs. Okay, actually S here is the elongation. Okay, restoring force Fs equals to Ks, where K is the spring constant and S is the elongation. Okay, after the mass attached at the end of the spring, it stretched the spring by an amount of S. And it's attained equilibrium position. Okay, when here we have the equilibrium position, F equals to W. So W is mg. W equals to mg. So in the system we have restoring force which act upward, so Fs, and we also have the gravitational force Fg which act downward. Okay, the thing you need to remember is when the force act upward, the sign is negative. When the force acts downward, the sign is positive. Okay, so the total force equals to Fs plus Fg, and our Fs is Ks. Mg is, okay, remember Fs act upward, so the sign is negative. Fg act downward, so Fg is mg, so plus mg. Okay, so at equilibrium position, mg minus ks equals to 0. So mg equals to ks. Okay, then for the third image, see here, if the mass is displaced by an amount of x here from its equilibrium position, so the restoring force of the system, okay, restoring force of the system, Fs equals to Kx plus S. Okay, assume there is no external force, so we can equate the Newton's second law by m d square x over dt square equals to negative k x plus s plus mg. Or we can write m d square x over dt square equals to negative kx minus ks plus mg. Since mg equals to ks at equilibrium position, so negative mg plus mg, so we can cancel mg. So it's become m d square x over dt square equals to negative kx. So this is the equation for free undamped motion. Okay, the second is for free damped motion. Okay, for free damped motion, for this part, okay, we have damping device attached at the end of the spring. So for this case, the equation will become m d square x over dt square equals to negative kx, and we have additional damping force, so minus, since okay, damping force acting upward, FD here is damping force, so negative kx minus FD, our FD is beta dx dt. Beta here is the damping constant. Okay, positive damping constant. Okay, this is for the second condition. This is for the first one, free undamped motion. This is for the second one, free damped motion. Okay, then the last one, when we have driven motion. Okay, means when we have external force. Okay, so when we have external force, we have to add additional part, which is m d square x over dt square equals to minus kx minus beta delta x over delta t plus external force Ft. External force acts downward, so the sign is positive. Okay, this equation, when we have damping constant, damping device. If we don't have damping device, so the equation will become m d square x over dt square equals to negative kx plus Ft, if we have the driven motion. Okay, for example, okay, a force of 400 Newton stretch a spring by 2 meter. Then a mass of 50 kg is attached to the end of the spring and released from the equilibrium position with an upward velocity of 10 meters per second. Find the equation of motion of the mass. Okay, here. A force of 400 Newton means we have F equals to Ks. Okay, F equals to Ks. Okay, our force is 400 Newton, and our K, we don't know the K, spring constant, so K. S is the elongation, so our S is 2 meters, so 2. So our K is 400 divided by 2 equals to 200. So our spring constant is 200. Okay, from the question here, there is no external force and there is no damping device. So, means our equation is m d square x over dt square equals to minus ks. Okay, so Mass is 50 kg. So 50, we substitute into the equation. M d square x over dt square equals to minus k. Our k is 200. Our s is, our x is, so here x, actually here is x. Here is x. Okay, so we have 50 x double prime plus 200 x equals to 0. So we can simplify this. We have x double prime plus 4x equals to 0. Okay, from this second order differential equation, we can transform into auxiliary equation. M square plus 4m equals to, m square plus 4, since m here, x, just x, not x prime. So m square plus 4 equals to 0. Okay, we can solve by using formula, or you can use your calculator. So we will have m equals to plus minus 2i. Okay, this is complex conjugate roots. So our solution will become xt equals to c1 cos 2t plus c2 sine 2t. Okay, that's the answer. Okay, for example number 2. Okay, a mass of 1 slug is attached to a spring whose constant is 5 pounds per feet. Initially, the mass released 1 foot below the equilibrium position with a downward velocity of 5 feet per second, and the subsequent motion takes place in a medium that offers damping force numerically equals to 2 times instantaneous velocity. Find the equation of motion if the mass is driven by external force. Okay, so it means we have external force, Ft equals to 12 cos 2t plus 3 sine 2t. Okay, for this, so it means we have a damping force and external force. So our equation become m d square x over dt square equals to minus kx minus beta dx dt plus ft. Okay, so our mass m is 1, so it's become d square x over dt square and spring constant is 5 pounds per feet, so minus 5x minus, okay, then the damping force that it numerically equals to 2 times instantaneous velocity, so it means 2 times instantaneous velocity. Dx dt is instantaneous velocity plus ft. Our ft is 12 cos 2t plus 3 sine 2t. Okay, so d square x over dt square plus 5x plus 2 dx dt equals to 12 cos 2t plus 3 sine 2t. So we come here x double prime plus 2x prime plus 5x equals to 12 cos 2t plus 3 sine 2t. Okay, so here, since the equation is not equals to 0, means we have non-homogeneous equation. Okay, when you have non-homogeneous equation, you need to find xp and xc, means the particular solution and complementary solution. Okay, we can transform into auxiliary equation. It's become m squared plus 2m plus 5 equals to 0. Okay, we will have m equals to -1 plus 2i. So complex conjugate root, our xc will become e negative t cos 2t plus sine 2t. Okay, this is for xc. Okay, since we have external force Ft here, and when we have the equation not equals to 0, means we have to find xp. So for particular solution, you can use undetermined coefficient method, or variation of parameter. Okay, the final answer for this question, okay, you can solve by yourself. xt equals to e negative t cos 2t plus 3 sine 2t. Okay, you will have this final answer. Okay, that's all for spring mass system. Okay, next video we'll continue with RLC circuit. Okay, thank you. Assalamualaikum.